Okay, this is Dr. Kling, and I'm continuing my review of linear equations. And in economics, we often encounter two linear equations in the same variable. So what would that look like? That would look like a0 plus a1x plus a2y equals 0. Now in our last video, that's exactly what we had. That's one equation. And now we'll have another equation. b0 plus b1x plus b2y equals 0. And that's called a system of two equations and two unknowns. The unknowns are our variables x and y, and the things with the a's and the b's are coefficients. So they would be numbers that are given, or they would be given constants. So that's two equations and two unknowns. And on a graph, it might look like there's y and x. If one of them is upward sloping and one of them is downward sloping, it might look like that. If they're both upward sloping, it might look like this. Either way, the intersection point, and I'll focus on this one, the intersection point is the solution, and in economics it's often interpreted as an equilibrium. But the solution is that point where the two lines meet. So that's one way of solving two equations, is to graph them, find out where they intersect, and that's the solution. And we're often interested in the solution in economics. We think of that as an equilibrium or a natural outcome when we've represented something as two equations. Okay, so another way to get to a solution is what I'll call repeated numerical substitution. Repeated numerical substitution. And the way we get that is we solve one equation for the x variable, and then solve the other for the y, and then substitute. So let's say we've already done this. Let's say we have y is equal to 10 minus x is one equation. And the other equation is x is equal to 1/2 y plus 1. And so repeated numerical substitution, we would just start by guessing the solution. So let's say we'll guess x is 0. We plug 0 into 10 minus x for y. So we go here first. X is 0, y is 10 minus x, then we guess y is 10. Now if we put y equals 10 into here and we get x is 0, we can stop. That is, we're going to keep getting the same thing over again. But let's see what happens. We'll put y equals 10 in here, and then we get half of 10 is 5, plus 1 is 6. And so now our next guess for x is going to be 6. Now we go back to this equation up at the top, and we get y is equal to 10 minus 6 is 4. And then we'll put 4 into this one, and we get x is 3. Now we put that into here, and y is 7. Just a second here. Okay, so and on the next round, we're back to this equation, putting a 7 in for y, and we get x is now going to be 4.5, which means that if we go back up here, y is going to be 5.5, The next round for x is 3.75. Next round for y will then be 6.25. We keep doing this, and eventually it'll turn out that x will get closer and closer to 4. You see it's kind of vibrating around 4. And y will get closer and closer to 6 because it's vibrating around 6. So now, with that, the numerical substitution is essentially kind of crawling around this graph until you wind up at the solution. That's the kind of what we're doing graphically. Now, I assume you remember how to solve this thing, which is let's take the case y equals 10 minus x. Y equals 10 minus x, and x equals 1/2 y plus 1. We can substitute this equation in for x here. So we get y equals 10 minus 1/2 y minus 1. Remember, we're subtracting both of these things. So that's going to be equal to 9 minus 1/2 y. We move the 1/2 y over. Just a second, let me get the... So we move the 1/2 y over, and so we get 1.5 y is equal to 9, or y equals 6, which is what I said we were converging on before. And then we go back to the x equation, and we say then x is equal to 1/2 y plus 1 is x equals 4. So that's our story. Y equals 6, x equals 4. That's our solution. So the general rule for solving, so we have many ways of solving two equations, but the general thing we can say about it is that step 1 is we solve one equation for y, solve the other for x. We plug what we got for 2 into 1. We collect terms in y, and so on. So let me just do the most general case. So we have a0 plus a1 x plus a2y equals 0. b0 plus b1x plus b2y equals 0. So the step 1 is to solve for the first equation for y. So that means y is going to be equal to negative a0 minus a1x all over a2. And then we're going to solve the second equation for x. And that's x is going to be equal to, I'm doing a lot of algebra in my head here, negative b0 minus b2y all over b1. Now we're going to plug this into that for x. So we're going to say y is equal to negative a0 minus a1 times negative b0 minus b2y over b1 all over a2. So it's equal to, let me get some more blackboard here. It's equal to negative a0 over a2 let's say plus a1 b0 over b1 a2 plus a1 b2 over b1 y. Okay, then we will pull this, next step is to collect terms in y. So we're still solving for y, so we we move this over, so you get y minus a1 b2 over b1 times y is equal to negative a0 over a2 plus a1 b0 over b1 a2. And now we can collect terms in y, so we can say y times 1 minus a1 b2 over b1 is equal to the same thing. Then we divide by this over here. So it looks like an algebraic mess, but it eventually can be solved. It's actually a lot easier when you have numbers. So that's, again, just a quick review of two equations and two unknowns. Whenever you see them, you can always solve them by the steps that I outlined up here, which is you solve one of the equations for one of the variables, you solve the other equation for the other variable, then plug the second equation into the first one, collect terms in the so now you're down to just one variable, because we've eliminated this variable by plugging it in here. So now we're down to one variable. You collect terms in that one variable, you solve for that variable, and you're done. And next time I'll talk about how to recognize a linear equation when it's walking down the street. And that's it.